Ask a struggling firm why a project went sideways, and you will hear a story about a single bad decision, the wrong consultant, a missing detail, a clash that surfaced too late in the BIM model. Ask a great firm the same question, and you will hear about a system that didn't catch the problem early enough, followed by the change to the system so the next project doesn't repeat it. That distinction is what PcM Module 3 is testing. This module is the practice-wide infrastructure underneath every project: quality assurance and quality control, office standards, BIM execution, consultant coordination, and professional development, including the AXP itself. 4 reasons firm-wide systems get their own module on the exam. 4 reasons firm-wide systems earn their own module. First, quality assurance and quality control are different disciplines, not synonyms. QA prevents defects by setting standards and procedures in advance. QC catches defects by reviewing the work after it exists. The exam will write a question that turns on which one the prompt is asking about, and the wrong answer choices will swap them. Second, office standards in CAD, BIM, drawing graphics, and specifications compound across years. Firms with disciplined standards inherit them on every project. Firms without relitigate every detail every time, and the cost shows up on the realization rate. Third, BIM is no longer an optional tooling decision. Level of development, BIM execution plans, and clash detection are tested directly on PcM. The exam expects you to know that LOD 300 is not the same as LOD 400. And fourth, consultant agreements under the AIAC 401 document carry indemnity, scope, and coordination obligations that bind the architect of record. The consultant's failures travel up the contractual chain. Here is the chronological tour of all 6 subsections. Walking the module in order. 2.1 names the hidden infrastructure, the systems that great firms have and struggling firms reinvent every project, plus the cost of not having them. 2.2 distinguishes quality assurance from quality control, walks the elements of each, breaks down QC review methods, and locks down the timing of QC reviews across the design phases. 2.3 covers the office standards taxonomy, CAD, BIM, drawing, specification, and the discipline of developing and maintaining standards so they don't decay. 2.4 walks BIM fundamentals for practice management, level of development levels 200 through 500, the BIM execution plan components, BIM coordination, and the clash detection process. 2.5 covers the architect's coordination role, consultant selection, the architect's coordination responsibilities under the AIA documents, and the key terms in a C401 consultant agreement. And 2.6 closes with knowledge management, the lessons learned process, professional development methods, and the AXP requirements that grow the next generation of licensees inside the firm. One posture set before we open section 2.1. 4 things to hold in mind. First, a great single project can come from individual talent. A great 100th project comes only from systems, and the exam rewards the candidate who reaches for the system answer over the heroic one. Second, quality assurance prevents, quality control catches. When the exam asks which discipline a procedure belongs to, the answer is rarely both. Pick the one the procedure actually performs. Third, BIM questions are about coordination discipline, not software preference. Level of development, BIM execution plans, clash detection, these are management topics dressed in modeling vocabulary. And fourth, consultant workflows through the architect's contract with the owner. The architect of record carries exposure for the consultant's failures, even when the consultant is a separate firm. The C401 consultant agreement is how that exposure gets distributed back. With that set, we step into section 2.1. Here is an uncomfortable truth most architects never want to hear. The best architecture firms are not the ones with the most talented designers. They're the ones with the most disciplined systems. 2 studios can hire from the same school, pay the same salaries, and produce work of equal quality on the boards. One delivers consistently on budget, the other lurches from crisis to crisis on every project. The difference is almost never talent. The difference is the infrastructure underneath the work, the documented, repeatable processes that operate the same way regardless of who is in the room that day. NCARB tests this material because the public is harmed when a firm cannot scale beyond the personal habits of its founder. Start by drawing a sharp line between what works for a solo practitioner and what a real firm actually requires. A practice-wide system is not a folder of templates, and it is not a written policy gathering dust on a server. It is a documented, repeatable, trainable process that produces the same quality result regardless of who is working on the project that week. A solo practitioner can run a firm entirely on personal memory and personal habit, because there is only one person making decisions, and that person is in every meeting. The day you add a second architect, half of what you know becomes invisible to the rest of the office. By the time a firm has 10 people, every undocumented habit becomes institutional fragility, the kind of risk that surfaces when the principal is on vacation and a client calls with a question nobody else can answer. There are 6 categories of practice-wide systems the exam expects you to recognize on site. 6 systems, and the failure mode each one prevents. Quality management is the discipline that catches errors before they reach the field, because the alternative is fighting fires and answering claims after the contractor has already built the mistake. Office standards keep every project consistent, drawing conventions, specification language, detail libraries, so that staff can move between teams without relearning everything. BIM and the broader technology stack enable coordination across disciplines, which is the only way to find vertical conflicts between ductwork and structure before the steel is in the air. Consultant coordination integrates structural, mechanical, and electrical into a unified design, and without an owner of that integration, every discipline assumes someone else checked the seams. Knowledge management captures lessons across projects, so the firm stops repeating the same expensive mistake on every job. And resource planning matches staff to workload, because the firm that burns out its best people on the hot project while another team sits idle is the firm that loses both kinds of people within a year. The reason these systems matter at all is the moment a firm crosses the line from one principal's habits to a real organization. The reason this material is on the exam is the curve of firm size. At one person, the firm runs on memory and nothing has to be written down because the architect is the firm. From 2 to 5 people, informal handoffs and a Friday afternoon conversation are usually enough to keep everyone aligned. Somewhere between 6 and 10 people, small lapses in coordination start surfacing as claims and rework. The volume of decisions exceeds what any one principal can keep in their head. At 10 and above, undocumented knowledge becomes institutional risk because every staff member who leaves takes a chunk of how things work with them. By 20 people, the systems are the firm. The firm is no longer the founder. And the day the firm is acquired or merged, only what is documented survives. Every uncodified habit gets stripped out by the new owner. Close on what this module is really testing and what to walk away knowing. 5 takeaways from this opening section. First, the firms that consistently deliver are not the firms with the most talented designers. They are the firms with the most disciplined systems, and the difference shows up in every metric that matters. Second, there are 6 practice-wide systems the exam expects you to recognize: quality management, office standards, BIM and technology, consultant coordination, knowledge management, and resource planning. Third, personal habit is enough when the firm is one person and breaks down somewhere between 5 and 10 people, which is exactly when most firms hit their first crisis. Fourth, undocumented knowledge becomes institutional risk as the firm scales. Every habit you never wrote down walks out the door with whoever knew it. And fifth, this module tests how firms actually operate at scale, not how a single project runs, because passing the exam means proving you can build quality into a process rather than perform it heroically once. Here is an uncomfortable truth most architects discover only after their first major claim. So let me make it concrete for you with a single real case. A 45-person firm designed a 4-story medical office building. During construction, the contractor discovered that ductwork conflicted with structural beams in 23 separate locations. Each conflict required a change order, field rework, and schedule recovery. The total direct cost came to $168,000, plus a 6-week schedule delay, a furious owner, and a claim that eventually settled for $95,000. The root cause was not bad design talent. The root cause was no BIM coordination, no clash detection, and no systematic review process. The mechanical engineer drew ductwork looking at 2-dimensional structural plans, and the vertical conflicts were simply invisible. Hold that number in your head, 168 in correction, and weigh what prevention would have cost. The number to remember is 14 to 1. $12,000 spent on proper BIM coordination and weekly clash detection meetings would have prevented $168,000 in change orders, plus a $95,000 settlement and a 6-week schedule slip. That is a return on investment of roughly 14 to 1, and it is not unusual. It is closer to the typical case than the outlier. Architects routinely treat the line item for coordination meetings and treat it as overhead worth cutting when the budget is tight. The firms that get sued for malpractice are the firms that cut exactly that line item on exactly the projects where the consequences were most expensive. Prevention is the cheapest money a firm ever spends, and it is the first money most principals want to save. And the reason prevention is so cheap is the curve of how correction cost scales once an error escapes design. Walk through what the same error costs at each phase of a project. Caught during design, the fix is a red line before drawings issue. Call it 1 times the original task cost. Caught during permitting, the same error has to be redesigned and resubmitted to the authority having jurisdiction, which runs roughly 5 times the base. Caught during bidding, you are now issuing addenda, possibly rebidding scopes, and absorbing contractor pricing impacts, so the multiplier climbs to about 10. Caught during construction, you are writing change orders, accepting schedule delay, and frequently absorbing some of the cost yourself to keep the client whole, which puts you at 50 to 100 times the base. And caught after occupancy, the error becomes litigation, remediation, and reputational damage, easily 100 times the original cost and sometimes far more. This is why every quality system the module covers earns its keep by moving error detection earlier in the timeline. Now examine what specifically breaks down when each of the underlying systems is missing. Here are the specific failures that surface when each underlying system is missing. Without quality management, coordination errors reach construction, which means change orders, RFIs, and ultimately claims when the contractor argues that the documents were defective. Without office standards, every project uses different layer names, different specification language, and different details, so staff cannot move between teams without effectively retraining. Every hour spent relearning conventions is an hour the client paid for and got nothing in return. Without real consultant coordination, structural does not fit mechanical. Grid lines drift between disciplines, and the contractor finds the conflicts in the field where they are most expensive to resolve. And without knowledge management, the same mistake repeats on the next project, because nobody captured the lesson from the last one, which is how a firm acquires a reputation for delivering trouble and slowly loses the referrals it used to count on. Close with the takeaway and the dollar logic behind it. 5 takeaways from the cost of operating without systems. First, the real case anchor. A 45-person firm, 23 coordination conflicts, $168,000 in direct rework, and a $95,000 settlement, all of it preventable for $12,000. Second, The prevention return on investment in that case was roughly 14 to 1, which is closer to the typical outcome than to an outlier. Third, the cost of fixing an error compounds sharply with each phase, from 1 times the original task cost in design to 50 or 100 times during construction and beyond after occupancy. Fourth, each missing practice-wide system produces a specific failure mode: coordination errors, wasted training hours, field conflicts, repeated mistakes. And each one carries a specific dollar cost the principal eventually pays. And fifth, quality systems are not overhead the firm tolerates. They are the cheapest insurance a firm ever buys. And the firms that treat them as cuttable are the firms that show up on the wrong side of a claim. Here is an uncomfortable truth most architects get wrong on the exam. Quality management comes down to a single, sharp distinction that you have to read carefully every time. Quality assurance, abbreviated QA, is everything a firm does to prevent errors from happening in the first place. Quality control, abbreviated QC, is everything a firm does to detect errors after the work has been produced. Architects routinely conflate the two terms in conversation, and on the exam, the wrong answer almost always swaps them. A standard operating procedure is QA. A peer review of a finished set is QC. A training program is QA. An interdiscipline coordination check at 60% construction documents is QC. The two disciplines need different people, different timing, and different mental habits. And a firm with only one of them is exposed on the side it ignored. Start with the cleanest definition, because the rest of the section depends on the line being drawn right. Hold these two sentences side by side. Quality assurance is the set of systematic activities built into the process itself so that quality requirements will be met. It is proactive. It happens before or during production, and everyone in the firm shares responsibility for it. Quality control is the set of operational techniques that verify quality requirements were actually met. It is reactive. It happens after production, and it is owned by specific reviewers whose job is to examine the finished work with fresh eyes. The mnemonic that sticks for most people is the letter trick. QA is for avoid. QC is for catch. Avoid the problem upstream or catch the problem before it reaches the contractor. The cleanest way to see the difference is to lay 4 dimensions side by side. Walk through the comparison column by column. On focus, QA is about prevention, designing the process so the error never enters the work in the first place, while QC is about detection, finding the error in the work after the fact. On timing, QA operates before or during production, while QC operates after production. On nature, QA is proactive and systemic, applying to every project the same way, while QC is reactive and instance-specific, applied to a particular drawing set on a particular day. And on the question being asked, QA asks, are we following the right process, while QC asks, did we produce the right result? Both questions matter. A firm that only asks the process question will produce a beautifully documented process that still ships sets with errors. A firm that only asks the result question will catch errors over and over and never fix the upstream cause. Which is why every serious firm runs both disciplines in parallel, and why the exam reliably tests this distinction. Here is why a mature firm runs both disciplines in parallel rather than choosing one. QA alone leaves you with a perfectly documented process that humans still violate under deadline pressure. The process is right, but errors still escape into the work. QC alone leaves you catching the same kinds of errors over and over because nothing upstream changed to prevent them, so the firm pays the cost of detection on every project forever. QA plus QC is the combination that actually works. The process prevents most errors, and the reviews catch the remainder. On the exam, the wrong answer in a quality management question almost always swaps the two definitions, so train yourself to read carefully when the question mentions one of them. And keep the memory device close. QA avoids problems, QC catches problems. Avoid versus catch is the line that survives every exam variant. Close with the 5 points that have to walk out of the section with you. 5 takeaways from quality assurance versus quality control. First, QA is prevention through process, and QC is detection through review. That single line is the most testable point in the module. Second, QA operates proactively before or during production, while QC operates reactively after production has finished. Third, the question QA asks is whether the firm is following the right process, while the question QC asks is whether the firm produced the right result. And both questions have to be answered every time. Fourth, mature firms run both layers in parallel, rather than choosing one, because QA alone leaves errors escaping through human variability, and QC alone keeps catching the same root causes forever. And fifth, the memory device that survives every exam variant is the letter trick. QA avoids problems, QC catches problems. Avoid versus catch. That is the wall between right answer and wrong answer. Here is an uncomfortable truth from most architects. Quality assurance is not a slogan, and it is not a poster on the break room wall that you walk past every morning. It is 6 concrete deliverables that mature firms write down, maintain, and train against. The reason firms invest in these deliverables is that quality has to survive 2 things every project encounters: staff turnover and deadline pressure. When the staff member who knew the firm's preferred detail leaves, the standard library is what keeps the next project from regressing. When the deadline compresses and the team is exhausted, the checklist is what keeps the obvious errors from shipping. QA elements turn personal habit into institutional practice, and the exam expects you to recognize them on site. Before listing them, draw a line between what QA actually is and what it gets mistaken for. Clear away the common misconceptions before listing the elements. QA is not a one-time audit that happens once a year and produces a binder. It is ongoing and built into every workflow. QA is not the same as QC, even though both serve quality. QA prevents the error from entering the work, while QC catches the error after the work is done, and a firm needs both. QA is not just templates sitting on a server. Templates without the procedures that govern their use and the training that teaches staff how to apply them produce inconsistent results, not standardized ones. QA is not optional when the deadline tightens. The firms that drop quality discipline first under pressure are reliably the firms that show up later on the wrong side of a claim. And QA is not the principal's job alone. It is process-focused, which means every team member owns their piece of it every day. With the misconceptions cleared, here are the 6 concrete elements every firm of scale puts in place. 6 elements, with what each one looks like inside a real firm. Standards are the documented requirements that govern the work, including the Office Standards Manual, the CAD layer conventions, the firm's preferred specification language. Procedures are the step-by-step processes for any task that repeats across projects, including the review workflow, the consultant coordination procedure, and the routing for a request for information. Training is the discipline of building staff competency on a continuing basis, with software training when a new tool is adopted, code update sessions when the IBC cycle changes, mentoring for new project architects. Templates are the starting points so that teams never begin from scratch on a deliverable that has been done 100 times. Drawing templates, specification masters, standard detail libraries. Checklists are systematic verification guides at key milestones. Code review checklists, coordination checklists, accessibility review checklists, and they exist because human memory is unreliable under deadline. And continuous improvement is the discipline of capturing and acting on lessons learned through post-project reviews and a lessons learned database that actually gets read by the next team facing the same problem. These 6 elements are not independent. They stack on top of each other in a specific order. The 6 elements stack in a specific sequence. Step 1 is standards. The firm defines what good actually looks like, in writing, so the requirement is not in someone's head. Step 2 is procedures. The firm specifies how that requirement is executed in practice, who does what, in what order, with what handoffs. Step 3 is training. The people doing the work are made capable of executing the procedure, because a written procedure no one is competent to follow is worse than no procedure at all. Step 4 is templates and checklists. The firm makes execution faster and more consistent by providing pre-built starting points and verification guides. And step 5 is continuous improvement. At the end of every project, the firm reviews what worked and what failed and updates the standards based on what it actually learned. Skip any step in the stack and the whole thing degrades. Standards without training are aspirational. Procedures without checklists rely on memory. Templates without continuous improvement freeze yesterday's mistakes into tomorrow's deliverables. Close with the recap, then the next section moves from prevention into the layered reviews that catch what QA misses. 5 takeaways from quality assurance elements. First, QA turns personal habit into institutional practice through 6 concrete deliverables, not slogans, not one-time audits, but ongoing artifacts the firm maintains and trains against. Second, the 6 elements are standards, procedures, training, templates, checklists, and continuous improvement, and recognizing the list on site is exam-testable knowledge. Third, the relationships among them matter. Standards define the requirement, procedures ensure the requirement is executed, and training ensures the people executing are actually capable. Fourth, the elements stack in a specific sequence, and skipping any step degrades the whole. Standards without training are aspirational. Templates without continuous improvement freeze yesterday's mistakes into tomorrow's deliverables. And fifth, QA prevents errors before they enter the work. And the next section covers the QC review methods that catch the errors which escape prevention. Peer review, discipline review, coordination review, and senior review. QA prevents errors from entering the work. QC catches the errors that escape prevention. And no single review catches everything. Effective quality control uses multiple layered reviews, each focused on a different category of issue, and each performed by a different person with a different kind of expertise. Skip a layer because the deadline is tight, and you are gambling that no error of the kind that layer was designed to catch is sitting in the documents. That gamble loses regularly. The Williams Engineering Center, a 4-story building designed by a 35-person firm, lost its permit and absorbed $67,000 in redesign because the team skipped peer review and rushed the principal review. The reviews that did not happen are exactly the ones that would have caught the issues. Start with the 6 review layers a mature firm runs in sequence and what each one is responsible for. Walk through the 6 layers in the order a project encounters them. Self-check happens during production, performed by the document author, and covers completeness and obvious errors. The author is the only person who can catch certain kinds of internal inconsistency in real time. Peer review happens after the initial work is complete, performed by a colleague at the same level, and exists specifically to bring fresh eyes to items the author has stared at too long to see. Discipline review happens at project milestones, performed by a technical expert in that specific area, and covers technical accuracy and code compliance, the kind of error that requires deep subject matter knowledge to spot. Coordination review happens before the set issues, performed by team leads from each discipline together, and covers cross-discipline conflicts where one trade's work collides with another's. Senior review happens before issue, performed by the project manager or principal, and covers overall quality and conformance to firm standards. An independent review happens at major milestones, performed by someone outside the project team entirely, and provides the objective assessment that no one inside the project can give honestly. The reason all 6 layers exist is that each one catches a category of error the others systematically miss. Here is why each layer cannot stand alone. Self-check catches typos and obvious gaps, but misses the author's blind spots. The assumptions baked in so deep the author cannot see them. Peer review catches logic errors and inconsistencies a fresh reader spots immediately, but misses deep technical issues the peer is not expert in. Discipline review catches code violations and technical errors the subject matter expert recognizes instantly, but misses cross-discipline conflicts where two correctly executed disciplines collide at the seam. Coordination review catches the conflicts between systems, ductwork through structure, plumbing through walls, doors swinging into accessibility clearances, but misses issues that live inside a single discipline. And senior review catches big picture problems like scope drift and standards conformance, but misses the minor detail-level errors that require staring at every sheet. Each layer is necessary because each layer is the only one that catches its specific category. There is no single review that catches everything. When a firm skips layers under deadline pressure, the failure mode is always the same. Here is the cascade in real numbers. Harper & Associates, a 28-person firm in Charlotte, was juggling 3 projects when their largest client demanded an accelerated construction document schedule on a $22 million ambulatory surgery center. Principal David Harper pulled staff from QC review duties to meet the deadline, telling himself the firm would do a thorough review during the addenda period. The documents went out with only a self-check by the authors. No peer review, no discipline coordination review, no senior review. Within the first 30 days of construction, the contractor submitted 47 RFIs on issues ranging from plumbing risers not matching floor plans to reflected ceiling plans showing diffusers inside structural beams. The medical gas system had no isolation valves at floor levels, which is a code violation the discipline review would have caught instantly. By month 3, the owner filed a formal claim alleging negligence, arguing that Harper's documents fell below the professional standard of care. Close with the 5 points that summarize how layered QC actually protects a firm. 5 takeaways from quality control methods. First, no single review catches everything. An effective quality control uses multiple layers in sequence, each focused on a category of error the others systematically miss. Second, the 6 layers are self-check, peer review, discipline review, coordination review, senior review, and independent review, and the exam expects you to recognize each one by purpose. Third, each layer catches a distinct class of issue. Self-check catches typos, peer review catches logic errors, discipline review catches code violations, coordination review catches cross-system conflicts, and senior review catches big picture problems. Independent review provides the objective outside assessment that no insider can give. Fourth, the most common QC failure mode is skipping a layer under deadline pressure, because the deadline always feels more urgent than the error that has not surfaced yet. And fifth, the Harper case is the canonical illustration. 47 RF is in 30 days, and a negligence claim from skipping reviews. It sits on the exam because it shows the exact cascade firms produce when they treat layered review as optional. Most architects say their firm does quality control. Far fewer firms do it at the right time. You see the difference at construction, when a clash that should have been caught at 50% CD becomes a change order that bills the owner 6 figures and exposes the firm to a lawsuit. QC is not a single event at the end of a phase. It is a sequence of checkpoints, each one targeted at a specific class of issue, and skipping any of them shifts the cost of catching that issue from cheap design time hours to expensive construction time dollars. The firm that schedules QC reviews only at issue dates has guaranteed that every problem found is a problem the team no longer has time to fix cleanly. Treat the timing of QC as the design decision it actually is. There are 5 milestones that matter, and each one targets a different class of issue. End of schematic design is the first checkpoint. You're checking design intent, program compliance, and whether the major system's direction makes sense. Get that wrong now, and you carry the error all the way to construction. End of design development is the second. The focus shifts to systems definition, coordination between disciplines, and the outline specs. 50% CD is the most important review in the entire sequence. Technical development is far enough along to test, but there's still time to fix what's broken without redrawing the whole set. 95% CD is the completeness review. Every sheet referenced, every specification aligned, every annotation present. And the pre-issue check is the deliverable assembly pass. Title blocks correct, printing legible, every sheet in the right set. 5 checkpoints, 5 different focus areas, and the firms that run all 5 are the firms whose construction phases stay quiet. The trap most firms fall into is treating every review the same. But early and late reviews have completely different jobs. Early reviews and late reviews are not the same activity, and treating them as if they are wastes both. An early review at end of SD, or 50% CD, is hunting for major issues: a wrong system, a missed program requirement, a coordination break between architecture and structure that hasn't been caught yet. At this stage, there is still time to redraw, re-coordinate, and even rebid if the design has drifted from what the client agreed to. Principals and senior technical staff lead these reviews because the questions are directional. A late review at 95% CD or pre-issue is hunting for completeness, a missing sheet reference, an unspecified product, a blank annotation, a call-out that points to a detail that does not exist. There is no time at this stage to redesign anything. The only honest goal is polish on what is already drawn. Detail-focused reviewers lead because the questions are about consistency. If the firm uses senior principals to hunt for typos and junior staff to validate system direction, both reviews fail. Skip any of the 5 and the consequences compound. Each missed milestone shifts the cost of the find downstream. Walk through what skipping each checkpoint actually costs the firm. Skip the end of SD review, and any program error or system misalignment carries forward into DD, where the cost of fixing it has multiplied because every dependent decision has now been built on top of the original mistake. Skip the end of DD review, and uncoordinated discipline drawings get baked into the CD set, which is where RFIs from bidders start arriving and the firm has to issue addenda under deadline pressure. Skip the 50% CD review, and any technical error gets carried into the 95% set, where there is no longer enough time to fix it cleanly. The team either ships a flawed set or burns through nights of overtime to patch it. Skip the 95% review, and inconsistencies go to bid in the CDs, which produces RFIs during construction and change orders the firm has to defend. And skip the pre-issue check, and stamped drawings leave the firm with errors the architect of record now owns legally because the seal binds the firm to what's shipped. 5 takeaways tie the timing discipline to the consequences it prevents. 5 takeaways on QC review timing. There are 5 milestones that matter: end of SD, end of DD, 50% CD, 95% CD, and the pre-issue check before the set ships. Each milestone targets a different class of issue, and they are not interchangeable. You cannot make up a missed early review with a more thorough late review. Early reviews hunt for big directional issues while there is still time to redraw, and late reviews hunt for completeness and polish when redesign is no longer an option. The 50% CD review is the single most valuable checkpoint in the entire sequence, because technical development is mature enough to test, but immature enough to fix. And the firms that skip reviews do not save the time they think they save. They shift the cost of finding each issue downstream into construction, where the same find costs 10 or 20 times what it would have cost at the right milestone. Most architects blame slow ramping new hires on the new hire. They shouldn't. The slow ramp is almost always a firm infrastructure problem you can see directly in the standards manual, or the absence of one. A new hire who walks into a practice with documented standards, layer conventions, detail libraries, sheet templates, naming rules, is producing useful work inside the first week and is at roughly 75% productivity within a month. The same hire walking into a firm with no standards spends weeks asking how things are organized on this project, only to discover the next project is organized completely differently. 6 months in, they are still asking the same questions, and you are still paying full salary for partial throughput. That is not a talent gap. That is a firm infrastructure failure, and a serious enough one to drive a malpractice lawsuit when a missed standard becomes a missed condition on a stamped drawing. Standards are not bureaucracy. They are the operating system the firm runs on. There are 6 categories of office standards, and most firms underinvest in at least 2 of them. Graphic standards cover layer naming, line weights, fonts, and dimension styles, the visual grammar of the firm's drawings. When a senior reviewer can read any sheet from any project without relearning the conventions, graphic standards are doing their job. CAD and BIM standards cover file naming, model organization, work sets, and family libraries. Without them, file management collapses and team handoffs lose hours. Detail standards are the standard detail library and typical assembly drawings, proven solutions that prevent every architect from redrawing a flashing detail from scratch on every project. Specification standards are master specs and standard language blocks that reduce drafting risk and shrink review time. Document standards are sheet layouts, title blocks, and cover sheets, the firm's professional appearance to clients and bidders. And process standards are the workflows, approval gates, and filing rules that govern how the firm runs day to day. Underinvest in any of these, and the gap shows up in throughput and quality on every project the firm touches. Having standards is not enough. They have to meet 5 conditions to actually deliver the productivity gain. A standard that doesn't meet all 5 of these conditions doesn't really exist, regardless of what the firm thinks it has. Documented is the first. If it's only in someone's head, the standard dies the day that person leaves. Accessible is the second. Staff have to be able to find the standard without asking a senior architect, because every interruption to ask a question is throughput the firm loses. Current is the third. Standards that haven't been touched in 3 years are now teaching the wrong practices because codes, software, and contracts have all moved on. Enforced is the fourth, and the one most firms fail. A standard filed away that nobody actually uses on projects is worse than no standard, because the firm has paid the cost of writing it and gets none of the productivity gain. And flexible is the fifth. A project-specific condition must be allowed to override a firm-wide rule when it should, without invalidating the rule for everything else. When standards are absent or broken, the productivity loss is measurable on every project the firm runs. Walk through what an unstandardized firm pays every week without realizing it. New hires take 6 months to reach the productivity level a standardized firm sees in 30 days, and during that ramp, the firm bills less and supports more. Senior staff lose hours every week answering questions about layer names, file locations, and detail conventions that should have been documented years ago. Cross-project staffing breaks down because every project is organized differently, so moving a team member from one job to another is essentially onboarding them again. QC reviews drag because reviewers have to relearn each project's conventions before they can even start looking for substantive issues. The same errors recur across projects because there's no detail library capturing what the firm learned the last 3 times it solved a similar problem. And brand consistency erodes. Every project's deliverables look like a different firm produced them, which clients notice even when they cannot articulate why. 5 takeaways pull the standards discussion into a single, firm-level discipline. 5 takeaways on office standards. There are 6 categories that every firm needs to standardize: graphic, CAD/BIM, detail, specification, document, and process. Underinvesting in any one of them shows up as throughput loss on every project. The productivity case is concrete. New hires ramp to 75% productivity in roughly 30 days at firms with real standards, and that ramp can take 6 months at firms without them. A standard that doesn't meet all 5 conditions, documented, accessible, current, enforced, and flexible, is not actually a standard, regardless of what the firm calls it. Standards that get filed away and never used are worse than no standards, because the firm has paid the cost of writing them and captures none of the benefit. And the deeper point is that standards protect creativity by not wasting it on the parts of the job that don't deserve it. So creative energy gets spent on design instead. Most architects who built their firm's standards built them once and never touched them again. The result is predictable. 3 years later, the standards reference code additions that no longer apply, software versions the firm has since upgraded past, and detail conventions that contradict what senior architects actually do on current projects. Staff stop trusting the document, work around it on every project, and you are back where you started, unstandardized in practice, with the added embarrassment of an outdated manual sitting on a shared drive. Standards are not a one-time project that finishes when version 1 ships. They are a living artifact that needs an explicit owner, an annual review cadence, and version control discipline. Skip the maintenance and the document becomes a personal liability exposure rather than an asset, because a stamped drawing built against a stale standard can drive a lawsuit straight back to the architect of record. The life cycle has 8 steps, and every one of them matters when the firm rolls out a real standards program. The life cycle starts with an honest needs assessment. Step 1. Identify the specific inconsistencies hurting current projects. QC reviewers wasting hours relearning layer conventions. Junior staff drafting the same flashing detail 3 different ways. Project managers fielding the same question on every kickoff. Step 2. Research best practices from industry standards, peer firms, and software vendor guidance, so the firm isn't reinventing what's already been solved. Step 3. Draft the standard with worked examples that show staff exactly what compliance looks like. Step 4. Pilot test on 2 or 3 live projects to surface what doesn't work in practice. Every standards program looks bulletproof until a real project tries to use it. Step 5. Refine based on pilot feedback before broad release, because rolling out a broken standard erodes credibility you may not recover. Step 6. Implement firm-wide with a single effective date and a named owner who is responsible for the document. Steps 7 and 8 follow. Train staff on the new standard with hands-on examples, and then maintain it. Annual review, version control, and updates triggered every time code or software changes meaningfully. Maintenance is the step that breaks most firms. Let me show you what triggers a real update and how often each one fires. 5 triggers force a real standards update. The firm needs a named owner whose calendar reflects each one. The annual review is the minimum, once a year on a scheduled date. The standards owner walks the document against current practice and catches accumulated drift. The code addition change is event-driven. The IBC runs on a 3-year cycle, and any standard referencing the prior edition is now teaching the wrong rules. Software upgrades are the trigger most firms forget. When the firm moves to a new version, the old screenshots and feature references mislead staff. Lessons learned from claims or QC misses are the highest value updates. Every time the firm absorbs a claim from a missed condition, the fix has to be captured in the standard. And a new service line is the 5th trigger. When the firm enters a new sector, the existing standards may not cover it and need to be extended. When maintenance lapses, the symptoms show up on projects before anyone notices the standards have rotted. 5 symptoms tell you the standards have rotted, and the firm should treat any one of them as a trigger to rebuild trust in the document. The first is that staff consistently work around the standard rather than follow it. When junior architects develop quiet shortcuts that contradict the manual has already lost its authority. The second is that QC reviewers stop citing the standard during reviews because they no longer trust what it says, and instead reference what senior architects do in practice. The third is that new hires ask senior architects basic questions the standard should already answer, which means the document either doesn't cover the situation or isn't accessible enough to find. The fourth is that two recent projects diverge on a convention the standard supposedly governs, which is direct evidence that the document is not being enforced. And the fifth is the simplest. The last modified date on the document is more than 18 months ago, which means the firm has skipped the annual review at least once, and the rot is now visible in the file metadata itself. 5 takeaways pull the maintenance discipline into a single ownership question. 5 takeaways on developing and maintaining standards. The life cycle has 8 steps: assess, research, draft, pilot, refine, implement, train, maintain, and every one of them matters when the firm rolls out a real program. Annual review is the absolute minimum cadence. Once a year, on a scheduled date, the standards owner walks the document against current practice. Beyond the annual cycle, 4 event-driven triggers force updates: a new IBC edition, a software version upgrade, lessons learned from a QC miss or claim, and a new service line the firm has entered. Standards need a named owner whose calendar reflects the maintenance schedule. Without that ownership, the document drifts and nobody is responsible. And outdated standards are actively worse than no standards at all, because they teach the wrong practices to drafters who trust the document. The firm pays the cost of writing it and absorbs the cost of being misled by it. Most architects whose firm bought BIM software did not actually buy BIM. They bought a 3D drafting tool and used it like one, drawing pretty models that look impressive in renderings but never get queried for clash detection, never get used for quantity takeoffs, and never coordinate across disciplines. The investment in licensing, hardware, and training looks the same as a real BIM rollout. The return is a fraction of what it should be. BIM is an information management process, not a piece of software. The model is the database is the coordination tool is what catches the clash that would have cost $10,000 in the field at $100 in the office. Confuse BIM with 3D, and your firm has paid for the platform without using it for the thing that pays back. And worse, you expose the firm to a lawsuit when a missed coordination becomes a field condition you'll have to defend. The cleanest way to understand what BIM is to put it next to what it is not. On the BIM is side, it's an information management process that runs through the entire project lifecycle, not just a deliverable phase. It's a collaboration methodology that coordinates architecture with structure and with MEP so that disciplines find conflicts in the model before the trades find them in the field. It's a queryable database that supports quantity takeoffs, simulations, and lifecycle decisions. And it's a tool that pushes better decisions earlier into the design when changes are cheap. On the BIM is not side. It is not just 3D modeling for renderings, regardless of how good the renderings look. It is not a single software package the firm bought. Revit alone is not BIM any more than Word alone is a publishing strategy. It is not a replacement for construction documents. The model produces the documents and the contractor still builds from the documents. And it is not automatic quality. The model is only as good as the discipline that built it. And a sloppy model is just as wrong as a sloppy drawing, with the added cost of pretending to be authoritative. The value proposition becomes concrete when you compare what the same project looks like with and without BIM. 5 concrete differences shape why BIM pays back. In the traditional approach, conflicts surface during construction, as RF is from the contractor, by which time the cost of fixing them has multiplied. In the BIM approach, the same conflicts surface during design as clash reports, where the fixed cost design hours instead of field dollars. Coordination in the traditional flow is 2D, done by overlaying discipline sheets and looking for misalignment by eye. In BIM, it is 3D and automated, and the clash engine finds conflicts the eye would miss. Information in the traditional flow is scattered across hundreds of drawings, while in BIM, there is a single source of truth, the coordinated model, and every drawing is a view of that model. Quantity takeoffs in the traditional flow are manual and slow, while in BIM, they pull directly from the model in minutes. And the largest difference is change propagation. In the traditional flow, every design change is pushed by hand across every dependent sheet, while in BIM, the change propagates automatically through the linked model. That alone justifies the investment on any complex project. Not every firm operates at the same BIM maturity. The industry sits on a 4-level scale. Maturity scale, and most firms are not where they think they are. Level 0 is no BIM, 2D CAD only, no coordinated model, no clash detection. Plenty of firms still operate here on small projects and call themselves BIM firms because they have a Revit license. Level 1 is partial BIM. 3D is used for visualization and renderings, but the documents themselves are still produced in 2D, and the model is not the source of truth. Level 2 is managed BIM, where each discipline maintains a coordinated model, and the disciplines exchange files at scheduled intervals to run clash detection. This is where most well-run firms actually operate today. Level 3 is integrated BIM, a single shared model in the cloud with real-time collaboration across disciplines and a single source of truth that updates as anyone touches it. Level 3 is still rare in US practice because it requires contract structures and software stacks that most projects don't yet support. But it's the direction the industry is moving, and the firms positioned for it will lead. 5 takeaways tie the BIM discussion to the firm-level investment decision. 5 takeaways on BIM fundamentals. BIM is fundamentally a process and a database, not a 3D model or a software package. Firms that confuse the platform with the practice pay for licensing without capturing the return. The core value proposition is moving conflicts from construction, where they cost field dollars, to design, where they cost office hours. Clash detection in the model is the single highest return feature of the entire approach. The model functions as a single source of truth. Every drawing is a view of the coordinated model, so changes propagate automatically instead of being chased across every dependent sheet. The industry runs on a 4-level maturity scale, and most firms today operate at Level 1 or Level 2, with Level 3 integrated BIM still rare in US practice. And the discipline-level truth is that the model is only as good as the inputs. A sloppy model is just as wrong as a sloppy drawing, with the added liability of pretending to be authoritative. Most architects read the D in LOD as detail. They shouldn't. It's the single most common BIM mistake in practice. And it's the mistake that costs you weeks of wasted modeling time on every project where it goes unchallenged. LOD stands for Level of Development. The distinction matters because it changes what the model is supposed to communicate at each phase. Level of detail is a graphic concept, how finely the geometry is drawn. Level of development is an information concept, how reliable the element is as a basis for downstream decisions. A schematic phase curtain wall should be modeled as a generic placeholder because the design will change. An architect who models every fastener at SD has invested weeks in geometry that carries no reliable information, and a missed coordination from that wasted detail can drive a lawsuit straight back to the firm. Per the BIM Forum LOD specification, LOD does not formally equate to AIA design phases. The project's BIM execution plan, or BEP, defines what LOD is required at each phase. Start with the formal definition, because the contract language in AIAG 202 binds your firm to it. LOD defines the reliability of each model element as a basis for downstream decisions, not how finely the geometry is drawn. The distinction is binding in contract because AIAG 202, the BIM protocol exhibit, uses LOD to govern what each party may rely on at each phase. An element at LOD 200 may render beautifully and look complete, but the contract says no party should rely on it for quantity takeoffs or coordination because the design intent has not yet been committed. Reading the geometry instead of the LOD designation is exactly the mistake that propagates through coordination meetings. One discipline assumes the curtain wall is accurate because it looks accurate, and rebuilds dependent structure and MEP routing against it. At DD, they discover the curtain wall was a placeholder, and everything that depended on it has to move. Per the BIM Forum spec, LOD does not formally equate to AIA phases. The project's BEP governs the required level at each phase. There are 6 LOD values defined, and each one means something specific. 6 LOD values cover the full project lifecycle, and each one means something specific about what downstream parties can rely on. LOD 100 is conceptual, a symbolic representation, useful for overall area or volume and nothing more. LOD 200 is approximate, generic placeholders with approximate geometry, commonly specified for schematic design when the system selections aren't yet committed. LOD 300 is precise, accurate size, shape, location, and orientation, the level at which dependent disciplines can start coordinating against the model, commonly specified for design development. LOD 350 adds connections, supports, and coordination interfaces, the bridge level between DD and CD where multidiscipline clash detection becomes meaningful. LOD 400 is fabrication level, shop drawing level detail, used by trades and fabricators rather than designers. And LOD 500 is as-built, field-verified information for facilities management. Worth noting that LOD 500 was dropped from the current BIM Forum specification, but still appears in AIAG 202 from 2013, which is the contract document many projects still reference. 4 common LOD mistakes appear on nearly every project that doesn't have a disciplined BEP. 4 mistakes show up on nearly every project that doesn't have a disciplined BEP. Overmodeling early is the most expensive. A BIM technician spends 3 weeks at SD modeling every fastener in a curtain wall. The client then switches manufacturers, and the entire detailed model is discarded. At LOD 200, the same curtain wall should have been a generic placeholder modeled in a fraction of the time. Undermodeling late is the inverse and equally damaging. The team never progresses past LOD 200 into the CD phase, so the clash detection runs on placeholder geometry that doesn't really clash with anything, and 40 conflicts that should have been caught in the model surface during construction as RFIs. Inconsistent LOD across elements is the silent killer. Some elements are at 300, others at 200, and the clash detection runs across a model where some conflicts are real and others are artifacts of the placeholder geometry. The team stops trusting the report, and no LOD requirements stated at all is the worst starting condition, because every discipline assumes a different level and coordination falls apart before it even starts. The BEP is what prevents all 4. 5 takeaways pull the LOD discussion into the BEP decision that governs every project. 5 takeaways on level of development. LOD is level of development, not level of detail. It defines how reliable each model element is as a basis for downstream decisions, not how finely the geometry is drawn. 6 values cover the full life cycle: 100, 200, 300, 350, 400, and 500. Each value binds what other parties may rely on at that phase. Per the BIM Forum LOD specification, LOD does not formally equate to AIA design phases. The project's BIM execution plan governs which LOD is required at each phase, and your firm should never let a project start without that BEP negotiated. AIA G202 is the contract exhibit that binds your firm to specific LOD obligations, so the BEP numbers translate into legal liability the moment the contract is signed. And the 2 costliest project errors are overmodeling early and inconsistent LOD across elements. Both burn hours and erode team trust in the coordination data. Every multi-firm BIM project that fails to coordinate fails for the same underlying reason. The disciplines never agreed on the rules before the modeling started. The BIM Execution Plan, or BEP, is the document that fixes that. It's a negotiated agreement among the architect, the engineers, and the contractor that defines how the model gets built, who is responsible for what, and how the work gets exchanged. Skipping the BEP is how you end up 8 weeks into construction discovering that the structural engineer was modeling at LOD 350, while the mechanical engineer was still at LOD 200, and nobody's models actually clash because half the elements are still placeholders. The BEP is the contract that prevents that conversation from ever happening. It's negotiated up front, in a meeting room, with every discipline in the same room, and once it's signed, it governs the project. The BEP has 6 standard sections, and every one of them prevents a specific kind of downstream failure. 6 core sections, each one foreclosing a specific way the coordination breaks down. Goals and uses comes first, because if the team can't articulate what BIM is supposed to accomplish, the rest of the document is performative. Visualization for the client, coordination among trades, energy analysis if sustainability targets demand it. Roles and responsibilities ends the argument over who owns which model and which deliverable. Model organization defines work sets, file naming conventions, and the shared origin point. Without a shared origin, the federated model literally won't align. Exchange requirements sets file formats and the cadence at which models change hands between firms. Coordination and quality control defines how clash detection runs, how each clash gets routed to a responsible discipline, and how models are reviewed and signed off before exchange. And deliverables defines what gets produced from the models at each phase, so the team isn't reinventing scope at every milestone. The reason each section matters is concrete. Every missing section maps to a known failure mode in the field. Each section earns its place by preventing a concrete failure. Missing goals or uses means the team models for its own habit rather than for the project's needs. Somebody puts in 2 weeks on energy analysis on a project that never required it. Missing roles produces the classic problem where 2 disciplines model the same wall. Neither one owns the clash report, and the conflict sits unresolved. A missing shared origin point is the killer that nobody sees coming. The federated model misaligns by a few feet, and clash detection becomes meaningless because every wall reads as a clash. Missing exchange cadence means engineers spend a week working over stale architectural backgrounds that were superseded 2 revisions ago. Missing clash workflow shows up as clash reports that get generated, sent around, and never actually assigned to anyone for resolution. And a missing quality control step is how bad models get exchanged, infect every downstream review, and pollute the federated model until somebody has to throw out a week of coordination and start over. Recap. Then we move into how the coordination itself plays out once the BEP is signed. 5 takeaways on the BEP. First, the BEP is negotiated before any modeling starts. Once it's signed, it governs the project, and it is the document that prevents most of the coordination disasters you'd otherwise spend the next 18 months recovering from. Second, the 6 standard sections cover goals and BIM uses, roles and responsibilities, model organization, exchange requirements, coordination and quality control, and deliverables, and each one earns its place. Third, coordination procedures and quality control are what turn clash detection into actual clash resolution. Without them, you get reports that nobody acts on. Fourth, every missing section maps to a specific field failure that's predictable in advance. And fifth, the BEP is essential the moment more than one firm touches the model, because once you have multiple disciplines exchanging files, the cost of an unwritten rule shows up immediately. The single largest return on BIM investment isn't the renderings, isn't the schedules, isn't the energy models. It's coordination. Finding conflicts in the model during design when fixing them is cheap, instead of in the field when fixing them is catastrophic. Every dollar a firm spends on BIM coordination has to be justified against the cost of not doing it, and the math is consistently lopsided once you start tracking the actual numbers. Coordination is not, however, a thing the software does on its own. It's a workflow, a sequence of model exchanges, clash runs, meeting reviews, ownership assignments, and rechecks. And every step of the workflow has a human owner who has to actually do the work. Firms that buy the software and skip the workflow get clash reports that nobody reads and conflicts that survive into construction anyway. The workflow has 7 steps, and every one of them has a clearly named owner. 7 steps, each with a named owner. The cadence starts when every discipline pushes its current model to the shared platform on the schedule the BEP defined. If a single discipline skips an exchange, the federated model is stale before clash detection even runs. The BIM coordinator then runs the clash matrix across the federated model. That's a software task, but the coordinator interprets the output, not the software. Team leads triage the clash report by severity before the coordination meeting, because walking into a meeting with 2,000 undifferentiated clashes is how you waste an hour of the entire consultant team's time. In the meeting, the project architect assigns every clash to one named owner with no exceptions. A clash without an owner is a clash that survives into construction. The responsible discipline modifies its model to eliminate the clash, and then the BIM coordinator reruns detection to confirm the resolution actually closed it. The loop only matters because every step has an owner. Clashes also come in distinct types, and the team has to know which type is which to assign and prioritize correctly. 4 clash types, each with its own pattern of response. A hard clash is the textbook case, 2 solid objects, like a duct and a structural beam, occupying the same physical space. The software catches these easily, and the resolution is mechanical. Somebody moves something. A soft clash is a clearance or access violation. The geometry doesn't overlap, but the maintenance worker can't reach the air handler, or the door can't swing because something's too close. Soft clashes require clearance rules to be defined in the BEP, otherwise the software has nothing to flag against. A 4-dimensional clash is a scheduling conflict where 2 trades are sequenced into the same space at the same time. That requires the schedule to be tied to the model, which is its own setup investment. And a workflow clash is the meta problem, where disciplines are using different reference grids or modeling conventions, and the federated model itself is incoherent. Workflow clashes have to be resolved before any of the other 3 even make sense. The exchange cadence and meeting cadence both step up as the project moves toward construction. Cadence is not a constant. It tracks design maturity and the risk of an unresolved conflict reaching the field. In schematic design, exchanges happen as needed, and meetings are biweekly. The model is too coarse for tight clash work, and the focus is on layout decisions. In design development, the cadence steps up to weekly exchanges and weekly meetings. Clashes are meaningful now and have to be resolved before they propagate. In construction documents, exchanges become twice weekly, while meetings stay weekly. Every clash carries higher rework cost, and the team cannot let stale models drive coordination. In construction administration, the cadence drops back to as needed. Exchanges respond to specific RFIs or change order activity, rather than ongoing design movement. When firms skip steps in this workflow to save coordination hours, the numbers from real projects are brutal. $340,000 is what Meridian Studios lost on a $28 million mixed-use project by skipping dedicated clash detection runs. The project architect decided bi-weekly coordination meetings were sufficient and cut the BIM coordinator's hours to save the firm $18,000 in fees. 8 weeks into construction, the contractor discovered 18-inch mechanical ductwork routed directly through a series of post-tensioned concrete beams in the parking garage. across 31 locations. The structural engineer had deepened the beams late in DD to handle revised loading, and the mechanical engineer never received the updated structural model. The damage came in pieces: $142,000 in mechanical rerouting, $88,000 in structural modifications where beams had to be cored and reinforced, a 9-week delay that triggered owner's liquidated damages, and a settlement of $112,000 from the E&O carrier. The $18,000 the firm saved bought $340,000 in damages. The lesson is structural. Clash detection and coordination meetings are not interchangeable, and skipping either one collapses the system. 5 takeaways on BIM coordination. First, coordination is the primary return on BIM investment, but only when the actual workflow is run. The software alone produces reports, not resolutions. Second, the 7-step workflow: exchange, detect, review, assign, resolve, verify, has a named owner at every step, and missing owners is how clashes survive into the field. Third, the 4 clash types are hard, soft, 4-dimensional, and workflow, and each one needs a different response and a different rule definition in the BEP. Fourth, the cadence intensifies as the project matures, from bi-weekly meetings in schematic design to twice-weekly exchanges in construction documents, because the cost of an unresolved clash rises sharply as documentation locks down. And fifth, clash detection finds problems while coordination meetings resolve them. Running one without the other, as Meridian Studios learned for $340,000, gives you the appearance of coordination without the function. Clash detection is the specific procedure inside the broader coordination workflow that actually finds the conflicts. The premise is simple. A federated model contains every discipline's geometry in one shared coordinate system. The software walks through that geometry and flags every place 2 elements occupy the same space, violate a clearance, or contradict each other. The procedure is mechanical, but the value depends entirely on when you do it. A conflict you find during design costs roughly 1 unit to fix: a model edit, a coordination meeting, a revised sheet. The same conflict found during construction costs 10 to 20 units because now there's labor in the field, material already installed, and a schedule that the resolution drags. The same conflict found after closeout costs 50 to 100 units because you're rebuilding completed work. The whole argument for spending money on detection during design is in those multipliers. The procedure itself has 6 discrete steps, and every step has to actually be performed. Aggregate first. Every consultant pushes its current model to the shared platform, and the BIM coordinator builds a federated file at a shared origin point. Run detection second. The software walks the geometry and produces the raw clash list, which on a normal building can run to several thousand items. Categorize third, because nobody can act on an undifferentiated list of 3,000 clashes. The team sorts by severity, by clash type, and by which 2 disciplines are intersecting. Assign responsibility fourth. Every clash routes to one named party with the project architect arbitrating disputes. Resolve fifth. The responsible discipline designs the modification, updates its model, and pushes the revision back to the shared platform. Document and verify sixth. The resolution is recorded so it survives team turnover, and detection is rerun to confirm the clash is actually closed. Clashes marked resolved without redetection frequently aren't. The cost of fixing the conflict you find depends on which phase you're in when you find it. These multipliers are why the math always favors investment in detection during design. A conflict caught during design is the baseline at 1 times the fixed cost. A model edit, a coordination meeting, a revised sheet, and the problem is gone. The same conflict surfacing during bidding costs 5 times that baseline. Because now the documents are issued and addenda have to be written, contractors have to reprice, and the project schedule may need to shift. The same conflict found during construction costs 10 to 20 times the baseline. The contractor is on site, material may already be installed, labor is being burned waiting for the fix, and the schedule impact often triggers liquidated damages. And the same conflict surfacing after closeout costs 50 to 100 times the baseline. Because now you're physically rebuilding completed work, often with a tenant in the space. Every hour spent finding clashes during design pays back at one of those multipliers. The takeaway is straightforward. Detection during design isn't an expense, it's a hedge. 5 takeaways on clash detection. First, the 6-step procedure runs aggregate, detect, categorize, assign, resolve, document, and verify. And every step has to actually be performed by a named owner, not assumed. Second, aggregation depends on a shared origin point defined in the BEP. Without it, the federated model misaligns and detection becomes a noise generator. Third, the cost of fixing the same conflict rises from 1 times in design to 5 times in bidding to 10 or 20 times in construction to 50 or 100 times after closeout. The multipliers are the entire economic argument for detection during design. Fourth, every clash needs one named owner. Unowned clashes survive into the field where they cost the maximum multiplier. And fifth, BIM coordination pays for itself the first time it catches a major conflict early, which on most projects happens before the end of design development. Most architects who run a project as lead consultant pick up liability the contract never assigned to them, and they pick it up by accident. On almost every conventional design project, you are the lead consultant, the party contracting with the owner and engaging the engineering disciplines under sub-consultant agreements. Lead consultant is a coordination role, not a supervision role, and that distinction is where most of the liability exposure lives. You integrate structural, mechanical, electrical, plumbing, civil, and specialty consultants into one coordinated set of construction documents. You do not perform the engineer's work, do not check their calculations, and do not assume their technical liability. What you do is run the meetings, distribute the information, manage the schedule, and ensure that the consultant's deliverables actually fit together. Architects who blur that line, directing an engineer's technical decision or guaranteeing an engineer's output, pick up liability that was never theirs. The coordination role is defined formally in the AIAB 101 Architect Owner Agreement. Section 3.1.4 of the AIAB 101 Owner Architect Agreement is where the coordination role is defined and bounded. The architect coordinates the architect's services with the services provided by the owner and the owner's consultants, which on most projects means structural, mechanical, electrical, plumbing, and civil engineers retained as sub-consultants. Coordination means integrating the consultant's design into a coordinated whole, running the coordination meetings, distributing drawings and revisions, setting the schedule, and resolving conflicts that arise between disciplines. What coordination explicitly does not include is responsibility for the consultant's professional engineering work. The structural engineer remains responsible for the structural design. The mechanical engineer remains responsible for the mechanical design. The architect's exposure is limited to whether the integration was performed competently, not whether the underlying engineering was correct. When the coordination role is performed well, the savings on a single meeting can be enormous. $400,000 is what one well-run weekly coordination meeting can save on a single conflict. On a complex laboratory project, the structural engineer had designed a transfer beam to carry lab equipment loads. The mechanical engineer had routed the main duct trunk directly through that same wall. The electrical engineer had planned the main distribution panel on the wall where the beam would land. 3 disciplines, 3 uncoordinated decisions, 1 wall. Caught in the model during DD, the conflict cost 4 hours of meeting time and 16 hours of redesign, about $8,000 total. If the same conflict had been discovered after construction started, concrete would have to be demolished, ductwork rerouted with a 6-week delay, the electrical panel relocated with a permit revision, an estimated $400,000. The difference was a project architect who insisted on weekly meetings with all disciplines in the same room, looking at the same federated model. The line that protects the architect from picking up the consultant's liability is what coordination is not. 4 common misconceptions, and each one converts a coordination role into something larger that the contract never paid for. The first misconception is that coordination means checking the consultant's technical work. It does not. The architect reviews for coordination, meaning whether the consultant's work fits with the rest of the design, not whether the engineering itself is correct. The second is that the architect guarantees the consultant's accuracy. The architect does not. The consultant is responsible for the consultant's own professional work and carries its own insurance for it. The third is that the architect directs the consultant's means and methods. The consultant determines how to perform its own work, in the same way a contractor determines means and methods of construction. And the fourth is that the architect re-engineers the consultant's design when problems surface. The architect doesn't hold the engineering expertise, doesn't hold the engineering license, and shouldn't be making engineering decisions on the consultant's behalf. That's how technical liability gets transferred to a party that was never paid to assume it. Recap. Then we move into how consultants are actually selected and engaged. 5 takeaways on the architect's coordination role. First, the architect is the lead consultant on a conventional project under AIAB 101, and that role is to coordinate the engineering disciplines, not to engineer them. Second, coordination means running the meetings, managing the schedule, distributing information, and resolving conflicts between disciplines. Operational work, not technical work. Third, the architect is not responsible for the consultant's professional engineering work. Each engineer remains responsible for its own design under its own license and insurance. Fourth, the economic case for taking coordination seriously is enormous. One well-run DD coordination meeting can save hundreds of thousands of dollars in field rework, as the laboratory example showed. And fifth, the architect who crosses the line into directing engineering decisions, guaranteeing consultant accuracy, or re-engineering consultant designs, imports liability the contract never assigned and the insurance never priced for. How you select consultants determines whether the coordination work you'll later supervise has any chance of succeeding. The federal standard for design professional procurement is Qualifications-Based Selection, or QBS, codified in the Brooks Act for federal projects and adopted as best practice for private work as well. The procedure is straightforward. Define the scope, identify firms capable of performing it, evaluate them on qualifications alone, rank them, and then negotiate fee with the top-ranked firm. Fee is the last variable, not the first. The alternative, selecting on the lowest fee and hoping the qualifications are adequate, is the procurement method that consistently produces the largest cost overruns, the most disputes, and the worst project outcomes. Architects who recommend lowest fee consultants typically end up named in the resulting lawsuit because the recommendation was theirs. QBS itself runs as a 7-step procurement procedure. Step 1 defines the scope clearly. Firms cannot demonstrate fit against a scope that hasn't been articulated. Step 2 builds the shortlist. Firms capable of performing the scope identified based on portfolio, references, and prior relationships. Step 3 issues a request for qualifications, an RFQ, soliciting experience, team composition, methodology, and references, but not fees. Asking for fees here contaminates the qualifications evaluation because reviewers cannot unsee them. Step 4 scores firms on qualifications alone, evaluating experience and project fit without reference to cost. Step 5 ranks the evaluated firms and produces an ordered list. Step 6 opens fee negotiation only with the top-ranked firm. The rest of the list does not get a chance to underbid them. And step 7 is the contingency. If negotiation with the top-ranked firm fails, that negotiation is closed out and the process moves to the next ranked firm. The top-ranked firm cannot be invited back to match a lower competitor's fee later. The reason QBS exists is that fee-based selection produces specific, predictable failure modes. Fee-based selection rewards firms that cut scope and cut quality to win the contract. The firm that knows what's in the scope and prices honestly always loses to the firm that prices a thinner version of the work. The bid itself becomes the goal, which means performance after award is a secondary concern. Underbid scope surfaces during construction as change orders, RFIs, and disputes. QBS inverts the incentive. By taking fee off the table during the evaluation, the procurement rewards demonstrated competence and project fit. Firms with strong qualifications can price honestly against a defined scope rather than racing to the bottom against firms willing to misrepresent what they intend to deliver. Quality outcomes are more likely. Scope is better understood entering the project, and the change order volume during construction is lower because the consultant priced the work the architect actually needed, not a stripped-down version of it. When QBS gets overruled by procurement pressure to chase the lowest fee, the numbers from actual projects make the case. $310,000 is what the Bridgewater Public Library Board paid for overruling a QBS recommendation on a $14 million project. The project architect recommended Thornton Structural Group based on QBS. Thornton had designed 7 libraries in the region and understood the unique structural challenges of long-span reading rooms and compact stack loading. Thornton's proposed fee was $168,000. The library board's facilities director overruled the recommendation and selected Reliant Engineering at $119,000, a $49,000 saving the board planned to put toward the children's wing. Reliant had never designed a library. During DD, they sized foundations based on standard office loading and missed the concentrated 150-pound per square foot live loads under the main book stacks. The error was caught by a third-party plan reviewer during permitting. The foundation redesign added $310,000 to construction cost. The project was delayed 14 weeks, and the children's wing was value engineered out entirely to cover the overrun. QBS protects against that pattern. The next section unpacks what the architect's coordination responsibilities actually cover once the consultants are engaged. 5 takeaways on consultant selection. First, QBS means qualifications first, fees second. Every variation of that order produces worse outcomes. Second, the Brooks Act mandates QBS for federal design procurement, and the same approach is widely treated as best practice on private work. Third, the 7-step procedure runs scope, shortlist, RFQ, evaluate, rank, negotiate, and move to the next firm if negotiation fails. Fee is the final variable, opened only with the top-ranked firm. Fourth, fee-based selection rewards firms willing to underbid the actual scope. The cut scope surfaces during construction as change orders, RFIs, and disputes that consistently exceed whatever the procurement saved. And fifth, the architect's coordination responsibilities, which is the next section, can only be performed effectively when the consultants are actually competent. Selecting them well is the foundation everything else rests on. The architect's role on every multidiscipline project sits on a single line, and the line is sharper than most architects realize. The architect coordinates the consultants. The architect does not become one of them. That distinction sounds obvious, until you watch a young project manager redline a structural drawing, override a mechanical engineer's load calculation, or sign off on an electrical detail the engineer was paid to take responsibility for. Every one of those moves quietly transfers liability from the consultant to the architect. And most of the architects who do it do not realize until the claim arrives years later. The B101 contract and the consultant agreements written under it are built to keep that line intact. Coordination is your job, engineering is theirs. The exam tests whether you can tell the difference under pressure. Start with the 7 coordination tasks the architect actually owns on every project. 7 tasks that belong to the architect on every project with consultants involved. Establishing design intent is first, because every other discipline calibrates against it. The structural engineer sizes members against your spans. The mechanical engineer sizes equipment against your envelope. And if intent shifts without notice, every consultant has to redesign. Setting the schedule means defining milestones and deliverable dates that work across disciplines, not just inside the architectural team. Distributing information is the mechanical task of making sure the latest drawings, specs, and changes reach every consultant who needs them. Missed distribution is one of the most common sources of construction phase rework. Facilitating meetings means running the coordination meeting and tracking action items afterward, because a meeting without follow-up is just a status update. Reviewing consultant documents means checking for design coordination, that the structural grid lines up with the architectural plan, that the mechanical room is sized for the equipment, not verifying the engineering itself. Resolving design conflicts is your seat when 2 disciplines collide and somebody has to decide which one moves. And managing changes is making sure that when one consultant updates, every downstream consultant learns about it in time to respond. The harder skill is recognizing where the line between coordination and engineering quietly gets crossed. Set the 2 columns side by side, and the boundary becomes operational. On the left side, every item is something the architect owns, establishing the communication protocols that route information across disciplines, conveying the design intent every consultant designs against, reviewing the work for design coordination only, and integrating the deliverables into a single, coherent bid set. On the right side, every item is something the architect must refuse to do, no matter how confident the request or how convenient the shortcut. The architect does not verify the consultant's engineering calculations. That is what the consultant's seal and professional liability insurance are for. The architect does not override the consultant's technical decisions, because the moment you do, you have taken responsibility for the outcome. The architect does not assume liability for the consultant's errors or omissions, and contractually, you must not let language drift into your agreement that does. And the architect does not guarantee the consultant's performance to the owner. Every crossing of that line transfers risk that the architect's policy was never priced to carry. The crossings tend to happen in a few predictable situations. Recognize them, and you avoid them. 6 moments where the line quietly gets crossed, almost always under schedule pressure. The first is redlining a consultant's drawing yourself, which is the cleanest way to take responsibility for something you were never paid to engineer. The correct move is returning the drawing with comments and letting the consultant make the changes under their own seal. The second is answering a contractor's RFI that belongs to the consultant. If the question is structural or mechanical, the RFI routes to the engineer, full stop. The third is approving a substitution that affects the consultant's design without bringing the consultant in to confirm. A contractor proposing a different chiller is a mechanical engineer decision, not an architectural one. The fourth is telling the consultant what to do instead of what is needed. Specify the outcome and let the engineer choose the means. The fifth is sealing a sheet outside your area of professional competence, which violates your license and your insurance at the same time. And the sixth is committing the consultant's deliverable to the owner on a date the consultant has not agreed to. You have made a promise on someone else's calendar. Close on the 5 takeaways that keep coordination from becoming engineering on accident. 5 takeaways from coordination responsibilities. First, the architect coordinates consultants but never becomes one of them. And that single sentence is the foundation of every contract document that defines the relationship. Second, 7 tasks belong to the architect on every multidiscipline project: design intent, schedule, information distribution, meeting facilitation, document review for coordination, conflict resolution, and change management. Third, when you review a consultant's work, you are checking for design coordination, not verifying the engineering, because verifying it transfers responsibility you were not paid to take. Fourth, every crossing of the line transfers liability from the consultant's policy onto yours, and your policy was not priced to carry engineering risk. And fifth, the crossings almost always happen under schedule pressure. Redlining drawings, answering the engineer's RFI, approving substitutions without bringing the consultant in. Name those moments, and you can refuse them in real time, which is what the exam is testing and what the practice actually requires. AIAC 401 is the standard form of agreement between an architect and a consultant, and it is the document most architects sign with the least attention. The signature gets treated as a formality, the terms get treated as boilerplate, and the consequences show up months later when something goes wrong and nobody can locate the clause that should have allocated the loss. C401 is not boilerplate. Every one of the 8 key terms inside it decides where risk lives, and a gap in any one of them can lead to the kind of lawsuit that bankrupts a firm. Scope decides what gets done, schedule decides when, compensation decides what it costs, and standard of care decides how well. Insurance, indemnification, ownership, and termination decide the financial consequences when something goes wrong. Miss anyone, and the agreement has a hole the next claim will find. Walk through the 8 terms one at a time, then tie them back to the principle that makes them work. 8 terms, 8 separate risk allocation decisions. Scope of services defines what the consultant has agreed to provide and prevents both gaps that nobody covers and duplication that nobody catches until billing. Schedule fixes milestones and deliverable dates that anchor the consultant to the project's critical path. Without it, the consultant prioritizes a different client's deadline and your project slips. Compensation establishes the fee structure and the payment terms. What gets paid, against what, and on what cadence. Standard of care sets the legal bar the consultant's work must meet, which is the level of skill ordinarily exercised by similar professionals in similar circumstances. Insurance specifies the coverage minimums and types. Professional liability is the central one, and creates the financial backstop when a claim lands. Indemnification allocates the consequences in money. Who pays when a problem traceable to the consultant causes damage? Ownership settles who keeps the instruments of service after the project ends, which affects copyright, reuse, and derivative work. And termination defines the exit ramp on both sides, how either party can end the agreement, and what happens to the work and the payments when they do. The 8 terms only work if a deeper principle is intact across all of them. The principle that makes the 8 terms work is called back-to-back, and it is one of the most tested concepts on PcM. Every C401 you sign sits underneath an owner-architect B101 that came first, and the C401 must pass the architect's upstream promises downstream to each consultant, term for term. Insurance is the clearest example. If the B101 requires $5 million in professional liability, the C401 must require at least $5 million from the consultant, never $1 million. Standard of care works the same way. The consultant's bar cannot sit lower than the architect's bar, because the architect cannot promise the owner a level the architect has not contracted for downstream. Indemnification is the finer point. B101-2017 has no general indemnification in the base contract and is typically negotiated in as a Section 11 modification, while C-401-2017 Section 10.1.3 requires the consultant to indemnify the architect for the consultant's own negligent acts. Every gap between the 2 agreements flows up the chain and lands on the architect as residual liability the firm was never priced to absorb. The cost of a gap is easiest to see when you set an aligned agreement next to a misaligned one. Set the 2 columns side by side, and the cost of a gap is plain. On the left, 4 common misalignments and what each one means in real money. The B101 requires $5 million in professional liability. The C401 only requires $1 million from the consultant. The $4 million gap is the architect's exposure on any claim that should have hit the consultant first. The B101 specifies an industry standard of care. The C401 leaves it undefined. The architect promised a level the consultant never contracted for. The B101 has an indemnification provision pushed in under Section 11. The C401 has no matching clause. The architect cannot pass indemnity through and absorbs the obligation alone. The C401 fee terms ignore the B101 milestone schedule. The consultant gets paid on a different cadence than the architect collects, and cash flow becomes the architect's problem. On the right, every row aligns. The insurance minimum matches or exceeds the upstream requirement. The standard of care is no looser than upstream. Section 10.1.3 indemnity mirrors the architect's negligence-only obligation, and consultant fee milestones tie directly to B101 phase deliverables. Aligned agreements move risk through the chain. Misaligned agreements stop the risk at the architect. Close on what you need to walk away knowing about C401 and the back-to-back principle. 5 takeaways from the consultant agreement section. First, C401 is not boilerplate. It is a deliberate allocation of risk in 8 specific terms, and signing it without reading it is one of the most common avoidable mistakes in firm practice. Second, 4 of the terms define the work itself: scope of services, schedule, compensation, and standard of care. A gap in any of them is a gap in what gets delivered to the client. Third, the other 4 govern the exit and the consequences: insurance, indemnification, ownership, and termination. A gap in any of them is a gap in who pays when something goes wrong. Fourth, the back-to-back principle is the rule that makes the structure work. The C401 must mirror what the B101 required of the architect, term by term, so risk flows through the chain rather than stopping at the architect's policy. And fifth, every B101 to C401 gap becomes residual liability the firm carries alone, and your insurer was never priced for it. Most architects assume the firm they work for has a way to find the knowledge it has already produced. It almost never does. Every architecture firm generates real knowledge every single day. A detail that finally solved a thermal bridge problem, a specification clause that survived 3 rounds of contractor negotiation, a scheduling approach that kept a difficult client calm through DD. The question is not whether the knowledge exists. The question is whether you can find it 6 months from now when a new project needs the same answer. In most firms, you cannot. The detail lives on someone's hard drive, the specification clause is buried in a folder nobody opens, and the scheduling approach walked out the door when the senior PM left for a competitor. Knowledge management is the discipline that turns scattered firm experience into a resource any staff member can use on the next project. And the firms that get it right compound that advantage year over year. Start with the basic distinction the AHPP draws between 2 fundamentally different kinds of knowledge. The textbook splits firm knowledge into 2 categories, and the practical difference between them shapes every system you build to capture either one. Explicit knowledge is documented and codified. Office standards, procedures, detail libraries, specification language. It exists in writing, in CAD files, in specification systems, and it can be filed, indexed, and searched by anyone with access. Tacit knowledge is the opposite. It is personal and experience-based. The senior architect's judgment about when a client is about to escalate, the project manager's intuition about which contractor will deliver on a tight schedule, the principal's relationship with a key consultant built over 15 years. Tacit knowledge lives in people, not in folders. And the moment those people leave the firm, the tacit knowledge leaves with them, unless someone has deliberately converted it into something explicit while there was still time. Both kinds need a system around them, and the AHPP describes a 5-stage process that handles each one. 5 stages, and each one fails differently when a firm skips it. Capture comes first because nothing else works if the knowledge is never written down. The typical tools are project archives at closeout and lessons learned templates filled in while the project is still fresh. Organize is the stage most firms quietly skip. They capture documents into a shared drive and assume someone will find them. But without taxonomy, tagging, and index search, the captured knowledge is functionally lost. Share is the active step of distributing what was captured to the staff who need it next. The vehicles are an intranet, internal training, and one-on-one mentoring between senior and junior staff. Apply is the test of whether the whole system actually works. Does any of this material show up in the templates the next project starts from, or in the standards the firm enforces? An update is the maintenance step, because knowledge that was right 5 years ago may be wrong today. Without a review cycle and a named owner for each major reference, the material drifts out of date. The reason firms invest in this discipline at all is the alternative. What happens when undocumented knowledge walks out the door? 6 ways undocumented knowledge quietly disappears from a firm. A senior staff member leaves for a competitor, and the curtain wall detail they refined over 4 projects leaves with them. The next team starts from a blank sheet on the same problem. A specification clause that was carefully negotiated to balance owner protection and contractor practicality survives in nobody's memory after the last person who knew the reason behind it retires. A trusted consultant relationship, built over a decade of small favors and clear communication, cannot be transferred to the next project manager because none of the context was ever written down. A hard-won fee negotiation that finally landed on the right structure for a difficult client never makes it into the firm's standard proposal language. A site-specific code interpretation, expensively obtained from a building official, gets relitigated on every new project in the same jurisdiction because nobody filed the official's response. And a favorite contractor's quirks, how they handle RFIs, what they want in a submittal, have to be relearned by every team because the institutional knowledge was never institutional in the first place. The closing question is whether the lessons captured at the end of each project ever change how the next one starts. 5 takeaways from knowledge management. First, every firm produces knowledge every single day. The firms that compound an advantage are the ones disciplined enough to find that knowledge again 6 months later. Second, explicit knowledge is documented and searchable, while tacit knowledge lives in people, and the 2 categories need different systems to preserve. Third, the AHPP describes a 5-stage strategy: capture, organize, share, apply, update, and every stage fails differently when it is skipped. Fourth, organize is the stage most firms quietly skip. They capture material into a shared drive and assume someone will find it later, but without taxonomy and index search, the knowledge is functionally lost. And fifth, the lessons learned a firm collects at project closeout are the single richest source of new explicit knowledge, but only if the firm has a process to convert those lessons into updated standards, which is exactly what the next section covers. Here is an uncomfortable truth most architects refuse to admit. Every firm you have ever worked for runs a lessons learned review at the end of every project, and almost none of them actually learn anything from it. The form gets filled out, the team puts an hour on the calendar, somebody types up the notes, and the document gets dropped into a shared drive nobody opens. A year later, the next project repeats the exact mistake. 2 years later, the same thing happens again. The firms that actually learn from their lessons learned are rare, and the difference between them and everyone else is not the form, not the template, and not the meeting. The difference is the discipline to convert each lesson into an updated firm standard before the team forgets it. Without that final step, lessons learned is a ritual. With it, it is the most reliable mechanism a firm has to stop repeating expensive mistakes. The AHPP describes a 6-step process, and exactly one of those steps separates ritual from result. 6 steps, and each one builds on the one before it. Step 1 is schedule. Set the review at project end or at the close of each major phase, not 3 months later when half the team has rolled onto other work and the details have already faded. Step 2 is gather. Survey the team for written input first, then run a facilitated discussion with explicit no-blame rules. Because the moment the conversation feels like a performance review, the honest content disappears. Step 3 is document. Record what worked, what did not, and specific recommendations the next project can act on. Vague conclusions like communication could be better are worth nothing. Step 4 is share. Distribute the findings to the staff who will work on similar projects next, and to the whole firm when the lessons apply broadly. Step 5 is apply. Update the firm's actual standards, details, procedures, and templates so the next project starts from the improved version. And step 6 is archive. Store the material in a searchable location so any future team can locate the original source. Step 5 is where almost every firm's process breaks down, and the symptoms are easy to spot. 6 warning signs that a firm is collecting lessons but not applying them. The first is the binder, a lessons learned document at the end of every project, growing thicker every year, while the firm's working standards look identical to a decade ago. The second is repetition. The same curtain wall detail fails the same way on 3 projects in a row, because the lesson from Project 1 never made it into the detail library before Project 2 started. The third is generational. Junior staff in their first 3 years make mistakes their senior architects made and documented years earlier, because nothing in the firm's onboarding captured the earlier lessons. The fourth is the standards themselves. If the firm's detail library, specification sections, and procedures have not changed in 5 years, the firm is not actually learning. The fifth is the project manager test. Ask any PM to name a single lesson from a past project that changed how the firm does the work, and watch what happens. And the sixth is structural. The lessons live in a separate document on a separate drive, instead of inside the standards they were supposed to improve. There is a single line that captures the entire dynamic, and the slide makes it the anchor of the section. Read that line slowly, because it is the one the exam will probe under a half-dozen different wordings. Lessons learned only create value when they change how the firm works on the next project, and skipping the apply step turns the whole exercise into theater. The first half defines value, not at the project that just closed, but at the project that has not started yet, because the lesson only pays off the second time. The second half names the failure mode. The meeting still happens, the form still gets filled out, the team still nods at the conclusions, but if nothing changes in the firm's standards, details, or templates, the entire process is theater. A firm that runs lessons learned reviews and never updates its standards is performing a ritual it has confused with a process, and it is performing it expensively every single year. Close on what you need to walk away knowing about the 6-step lessons learned process. 5 takeaways from the lessons learned process. First, every architecture firm collects lessons learned in some form, and almost none of them actually apply those lessons to change how the firm operates on the next project. Second, the AHPP defines a 6-step process: schedule, gather, document, share, apply, archive, and the steps build sequentially. Third, step 5, apply, is the one almost every firm skips because it requires somebody to actually update the firm's standards, details, procedures, and templates rather than just file a report. Fourth, the clearest warning sign that a firm has skipped the apply step is that its working standards have not changed in 5 years, despite an annual lessons learned ritual at every project close. And fifth, skip apply and the entire process is theater. The meeting still happens, the document still gets filed, the binder still grows thicker every year, and the same mistakes keep happening on every new project because nothing in the firm's working method ever changed. Most architects treat professional development as a perk the firm offers when it has time. It is not. It is a system the firm builds on purpose, the same way it builds a quality program or an office standard, and you ignore it at real cost. Architects practice in a field where code changes, materials change, contract forms change, and case law changes. And the architect who is not actively learning is quietly falling behind in ways the next project will expose. The American Institute of Architects requires 18 learning units every year to maintain membership, and most state boards require continuing education to renew the license itself. Skip those obligations, and you lose your license to practice in jurisdictions that enforce continuing education. You face board disciplinary action, and the firm itself loses its strongest people to competitors that actually invest in growing their staff. Start with the 6 methods the exam expects you to recognize as legitimate professional development. 6 methods, each one targeted at a different kind of growth. Formal training, structured courses and workshops, is the right tool for technical skills, software upgrades, and code updates, where the content is well-defined and the goal is competence on a specific topic. Mentoring is one-on-one guidance from a more experienced architect, and it is the only practical way to develop judgment, leadership, and the kind of nuanced decision-making no classroom teaches. Job rotation moves staff across project types and roles inside the firm, building breadth of experience and quietly creating succession depth so the firm does not depend on any single person. Conference attendance, including the American Institute of Architects Convention, exposes staff to trends, peers, and the broader profession in a way the office cannot replicate. Lunch and Learns are internal, short-form presentations during the workday, and they are the most underrated investment a firm makes. High knowledge transfer at almost no cost. And professional involvement in bodies like AIA and ULI builds the external network and leadership credentials that protect a career across decades. Each method buys something specific, and the choice depends on the gap you are trying to close. The mistake firms make is using one method for every gap, when each method is built to close a different kind of gap. Formal training is the right answer when the gap is well-defined. A new code cycle, a software migration, a specific fire-rated assembly the team has never detailed before. Mentoring is the right answer when the gap is judgment, because judgment cannot be taught in a classroom and only develops through guided exposure to real decisions. Job rotation closes single project type tunnel vision, which is the failure mode of staff who have only ever worked on one building type and cannot transfer the underlying principles. Conferences close insularity. The firm that never sends anyone outside its own walls slowly stops learning what its competitors and peers are actually doing. Lunch and Learns close internal silos, where one team has solved a problem another team is about to walk into for the first time. And professional involvement closes career stage gaps, building the kind of standing in the profession that protects a career across the decades when project work itself slows down. A firm that wants this to be a real system runs the same annual cycle every year. 5 steps that turn professional development from a wish list into an actual program. First, assess gaps every year at both the firm level and the individual level. What does the practice need to be capable of 12 months from now that it cannot do today? Second, build the plan by matching each gap to the method best suited to close it, because using mentoring for a software rollout or formal training for judgment development wastes both money and time. Third, budget and schedule the program. Allocate the hours, allocate the dollars, and put the events on the firm calendar before billable work claims every available slot. Fourth, track learning units against the American Institute of Architects' 18-unit annual obligation and any state continuing education rule, because the consequence of falling short is lapsed membership or a license renewal problem the firm cannot quietly fix later. And fifth, measure outcomes honestly. If retention, project quality, and staff capability did not improve, the plan was the wrong plan, and next year's program needs to look different. Close on the takeaways that carry forward into how the firm documents and verifies experience. 5 takeaways from this section. First, professional development is a firm-level system the practice builds on purpose, not a personal hobby staff pursue after hours. And treating it as the latter is how firms slowly fall behind the competition. Second, there are 6 recognized methods: formal training, mentoring, job rotation, conference attendance, lunch and learns, and professional involvement. And the exam expects you to recognize each one on site. Third, each method is designed to close a specific kind of gap, and matching the wrong tool to the wrong gap wastes both the training budget and the staff time it consumes. Fourth, the American Institute of Architects requires 18 learning units every year to maintain membership, and most state licensing boards add their own continuing education rules that the architect has to track separately. And fifth, the firm that skips this program does not save money. It loses its strongest people to the competitor that runs a real one, and replacing senior staff costs far more than the program ever would. Right after professional development comes the part of the framework that decides whether the path to licensure stays open. The Architectural Experience Program, AXP, is administered by NCARB, and it is the experience gate every candidate has to pass through. Most architects treat it as a logging exercise, hours dropped into a portal between project deadlines. That mindset is exactly why some candidates fail the exam path entirely or stall for years and face board disciplinary review when their reporting falls out of compliance. AXP is not a checkbox. It is the blueprint for the practice you are about to be licensed to run, and the 6 categories map directly to the 6 ARE divisions for a reason. NCARB is telling you what a competent architect actually does, and demanding that you do all of it before they certify you to do any of it alone. There are 6 experience categories, and each one carries a specific hour requirement you cannot substitute out of. 6 categories, 6 minimum hour requirements, and no way to substitute one for another. Practice management requires 160 hours and covers business operations, firm-level decisions, and the kind of work the PcM division tests on the exam. Project management requires 360 hours and covers the work of running a project: schedule, budget, contracts, and team coordination. Programming and analysis requires 260 hours and covers site analysis, programming, and the early conceptual work before a building takes shape. Project planning and design requires 1,080 hours and is where the design itself happens: schematic, design development, and the integration of building systems. Project development and documentation requires 1,520 hours, the largest single category, because construction documentation is where the most time on a real project is actually spent. And construction and evaluation requires 360 hours, covering construction administration, observation, and project closeout. Every candidate must hit every minimum. Add those 6 minimums together, and you arrive at the total benchmark every candidate has to clear: 3,740 hours. That is the total experience benchmark, roughly the equivalent of 2 years of full-time work in a licensed practice, and the number every candidate has to clear before NCARB will certify the experience portion of the licensure path. But the headline number hides a critical detail. Hours only count when they are verified by a licensed supervising architect, logged in the NCARB portal within the reporting window, and tied to one of the 6 approved experience categories. Hours the candidate worked but never submitted in the required window can be rejected entirely, and there is no appeal. NCARB also updates the program periodically. The hour breakdown current at the time of this lesson can change, so every candidate has to verify the live numbers at ncarb.org before relying on them for planning. 2 failure modes consume more years of candidate progress than anything else in the program. 6 rules that decide whether the hours actually count. First, only a licensed supervisor can verify hours. Work that nobody licensed signed off on never enters the official record, regardless of how real or substantial the experience was. Second, hours must be logged in the NCARB portal within the reporting window, and waiting until the end of a long project to enter everything at once is how candidates discover that older entries are no longer accepted. Third, every one of the 6 categories requires its own minimum, and an overflow of hours in project development and documentation does not satisfy a shortfall in practice management. There is no substitution rule. Fourth, routine office activity like staff meetings, internal administration, or unrelated firm tasks often does not qualify as AXP time, even when the candidate spent the hours. Fifth, miscategorization is the most common reason candidates lose months on the path. Entries get rejected and relogged, and the calendar runs out before the gap closes. And sixth, verify the current hour breakdown at ncarb.org before any exam attempt, because the program updates and outdated assumptions cost real time. Close on what to walk away knowing as the foundation underneath the licensure path. 5 takeaways from the AXP section. First, AXP organizes experience into 6 categories that mirror the 6 ARE divisions, and that alignment is deliberate. NCARB is mapping what an architect actually does to what the exam actually tests. Second, the required hours per category range from 160 hours in practice management to 1,520 hours in project development and documentation, and every minimum has to be hit independently with no substitution between categories. Third, the total benchmark is 3,740 hours across all 6 areas combined, roughly 2 years of full-time license practice experience when the categories are pursued in parallel. Fourth, only hours verified by a licensed supervising architect and logged within the reporting window count toward the official total. Unverified or late hours can be rejected entirely. And fifth, the program updates periodically, so every candidate has to verify the current NCARB rules before relying on any specific hour breakdown for planning. Module 3 has walked you through what looks at first like 6 unrelated topics: office systems, quality control, standards, building information modeling, consultants, and knowledge with professional development. They are not unrelated. Most architects who fail this division on the first attempt fail because they studied these as 6 separate topics. You should not. They are one answer to one question told in 6 chapters. The question is how an architecture firm scales beyond the personal habits of its founder into an actual practice that delivers consistent quality regardless of who is staffed on a given project. And the candidate who misses that through line fails the exam where every question expects you to see it. Let me pull the through line together one last time before you move on. Start with a 1 row per section recap of the entire module. 6 sections, 6 key points the exam expects you to hold simultaneously. Section 2.1 made the case that the firms that consistently deliver are not the ones with the most talented designers, but the ones with the most disciplined, documented systems. Section 2.2 drew the line between quality assurance, which prevents errors in the process before they happen, and quality control, which detects errors in the product after the work is done. Different disciplines, different timing, both required. Section 2.3 covered office standards as the mechanism that keeps every project consistent so staff can move between teams without relearning the firm's conventions every time. Section 2.4 covered building information modeling and the LOD scale, with the critical point that the BIM execution plan drives how LOD maps to project phases, not the level of development number alone. Section 2.5 covered consultant coordination, where the architect facilitates and integrates rather than directing technical work. The architect is not licensed to perform. And Section 2.6 covered knowledge management and professional development, where the central move is converting tacit knowledge into explicit documentation and growing staff capabilities on purpose rather than by accident. The second table worth carrying out of this module is the QC Review Milestone Schedule from Section 2.2. 4 QC review stages, each one targeting a different class of issue, and a firm that schedules all 4 catches problems while they are still cheap to fix. At the end of schematic design, the review focuses on design intent and program compliance. Does the building actually solve the problem the owner hired you to solve? At the end of design development, the focus shifts to coordination across the structural, mechanical, electrical, and plumbing disciplines, because every gap left at this stage becomes a clash in the documents and a change order in the field. At 50% construction documents, the review targets the technical accuracy of details and specifications, when there is still time to revise without disrupting the team's production rhythm. And at 95% construction documents, the focus is completeness. Every drawing referenced, every specification section accounted for, every consultant's deliverable in place before the set goes out for permit and bid. Pull the through line one final time before the closing recap. 6 statements that capture what this entire module was really teaching. First, a firm is its systems. The founder's personal habits and personal memory are not the firm. The documented, repeatable processes that anyone on staff can execute are the firm, and that distinction is the dividing line between a practice that scales and one that collapses when the principal takes a vacation. Second, quality is built into the process, not inspected into the product at the very end, which is why quality assurance and quality control are separate disciplines doing separate work. Third, office standards and building information modeling are the infrastructure that lets multiple projects run in parallel without each one reinventing the wheel. Fourth, consultants are coordinated by the architect, who integrates their work into a unified design, but consultants are not directed in their technical specialties. That line protects the architect from liability for work the architect is not licensed to perform. Fifth, knowledge that has been made explicit through documentation outlives the staff who originally learned it, and a firm that does not capture knowledge loses it every time someone leaves. And sixth, professional development and the AXP Experience program are how both the firm and the individual architect stay current with codes, materials, contracts, and the standards the profession itself keeps moving forward. Close with the 5 takeaways that should travel with you into the rest of the division. 5 things to walk away knowing from Module 3. First, a firm is its documented systems, and the moment headcount crosses roughly 10 people, personal habit and informal handoffs stop being enough. Every undocumented practice becomes institutional risk that surfaces at the worst possible time. Second, quality assurance prevents errors in the process, while quality control detects errors in the product. And the 4 review stages, end of schematic design, end of design development, 50% construction documents, and 95% construction documents, each target a different class of issue. Third, the Building Information Modeling Execution Plan, not the level of development number, controls how LOD maps to a project's phases, and assuming otherwise is exactly the kind of trap the exam is built to expose. Fourth, the architect facilitates and integrates consultant work, but never directs technical specialty decisions, because that line is what keeps the architect from being liable for work performed under another professional's license. And fifth, the AXP Experience program requires 3,740 hours distributed across 6 categories that mirror the 6 ARE divisions, with no substitution between categories and supervisor verification on every hour that counts.